to my channel Kajidataonline. In this video, I'm not going to explain about the Arduino kit. However, I'm going to explore a very interesting topic with regard to the testing the capacity of the battery. So this idea is very useful because I recently have the challenge, and then I also bought a few batteries that are possibly fake battery, and then idea how you are going to test your battery output and also their capacity, and then we are going to use the internet connectivity so that we have the idea when is the startup Arduino setup are going to be shut off due to the limited power supply by your battery capacity. Okay, so let me share my screen. So the altimeter is a very useful device for you to detect and also make some measurement with regard to the electronics kit. So what I have here is a battery. This is claimed to be 4800 milliamp, and then we are going to see whether this battery are fully capable of delivering this 4000 milliamp. So before that, let me just observe the power of the battery. Okay. Right. So this is the fully charged battery actually. So to test this one with my kit over here. So this is my air quality kit. So my air quality kit are actually being set up using the ESP01 module over here. So ESP01 module connected with the Arduino Nano, and then having the EHT10 sensor. So EHT10 is one of the temperature and relative humidity sensor. So we are going to connect this setup using the Thingspeak website. So under the Thingspeak, we are going to light it on, and then we are going to see how long is it take for this item to log the data, and then until when the data are going to be stopped logging. And then we are going to use also the battery shield over here. So this battery shield equipped with the charger doctor. So the charger doctor are very useful for you to measure the current, how many current are going to be withdrawn based on the connectivity between your Arduino as a load and also your battery. So based on that, we can see how many amp are going to be generated, and then we can possibly make an hypothesis on how long is it take before the battery dries off and then not operating anymore. Okay, so without further ado, let's go to the setup of our computer so that we can sort of clear the existing data. So if you can see here, I got the 2244 data. So I might want to go to the channel setting and basically remove everything. So I'm going to remove every data that already been logged before. One of the reason is because I really want to investigate these issues to make sure that my data are capable of recording the appropriate number of data based on the claim of this particular seller. So the seller possibly say that this is the battery that can supply with this amount of capacity. So let us have a look. So the first one, of course, we need to connect it with our battery shield. And then you can see over here, we get 5 indicator, indicate that this is a fully charged battery. And then we can insert this cable. The cables are connected with the Arduino Nano, and then we can see it's delivering approximate of 0.12 or 120 milliamp. So 120 milliamp are going to be set as our cut off, and then we are going to observe over here on our Thingspeak. So when the data is logged, so that's mean we begin our initial startup. All right, so to begin with, of course, maybe some of the resistance or some of the power from this device might be interfere. So therefore, we just want to connect this one first and then see how many amps are going to be withdrawn. from our battery towards our load at the Arduino Nano and also USB module together with the sensor. Therefore, I'm going to detach this one because we know already the approximate current that already being flow, and then we are connecting directly with our battery shield. So this battery shield are producing approximately 5 volt with the 3 amp. At the moment just now we see that it is around 120. So we shall see what kind of output are going to be generated on our Thingspeak website. So let me just wait for a while, and then possibly because this is the new connection from our new battery, and then this is also a new platform that we refresh it already, we might want to consider to reset it first so that our ESP are going to be initialized and the data are going to be locked accordingly. So the data is will be locked at the interval of 1 minute. Okay, so let me just show you the data and also the setup of my device so that you can have an idea about this setup and experiment. So this is the beginning and the startup point of our experiment. It's around 12:10 a.m. in Malaysia time. So we shall see in a few hours from now how long this setup are going to be withstand with this current use of the battery, which is the 4800 milliamp as claimed by the supplier. So let's just wait for a while to make sure that the data is already logged for the next one. Okay, yeah, we got the second data here on the humidity side. Okay, so the humidity is recorded 78. Okay, so we got the second data also on the temperature. So this is the idea of the temperature and humidity sensor that already being detected by our AHT10. So this is 12:10. This is the 12:11. So approximate 1 minute. So every 1 minute the data are going to be logged. No sleep mechanism. It's just a pure delay with regard to the 60,000 milliseconds. 60,000 milliseconds means that one minute. Every 1 minute the data are going to be logged. Every 1 minute the data are going to be logged in our Thingspeak. So I'm going to discuss also the next setup because this is the primary setup for the EHT model, and then I have another model which is consider a robust module also, which is the Wi-Fi module, which is the WeMOS. Put it away, and then basically we are going to put it somewhere there on the shelf so that we can monitor it later on. So now we are back. So our second experiment, we are going to explore also the data that are going to be collected and connected by this device. Okay, so this is the second device where I'm going to connect it with the I/O Adafruit I/O on this feed. Okay, let me just give you an idea. So this is the previous data that already been logged. What I'm going to do is basically I'm going to remove all the feed. But of course, I need to remember the name of the feed, which is the SHT 21 underscore RH. So please allow me to do some manipulation where I'm going to delete the feed and then create the feed again. So by doing this, basically SHT21 underscore RH, basically we are trying to create a new fresh data from our sensor. And then we are also going to know whether the battery that we tested in this experiment are quite useful and give us a very good result in terms of the performance of their battery capacity. Okay, so let me just put a few items over here. Interesting idea because we we do it in a live so that we know already what is the step taken for doing this. Being set up like this. This is the Wemos D1 where we connect the SHT21. So this is the SHT21 sensor. Let me zoom a little bit so that you can have an idea how I set it up. So using the VIN, ground, SEL and SDA, we connect it at the 3.3 volt over here, and then ground, and the SDA and SEL. And then we are going to use the basic 3.7 volt. However, as you know, that the Wemos possibly run using the nominal 5 volt. Therefore, I'm going to use the step up converter over here, where I no longer insert the 5 volt. Instead of that, I'm going to use the 8 volt because of the connectivity of the internet and so on. So we want to challenge it, how many volt are going to be produced by this item. So let me just quickly put the battery over here, and then we can see the volt that are going to be generated by our module. So this is the positive and negative, if you can see on our multimeter over here. Okay, so that is the idea. We got around 8 volt, 8 volt from our 3.7 volt battery, and then we are connecting it on our Wemos D1 with the SHT21 sensor. So let us have a look what happened. All right, so as expected, the temperature and relative humidity data are already being logged inside our Adafruit IO. So now we can see that the startup is begin before at the 12:22 a.m. early in the morning Malaysia time. So we are going to observe how long is it take before it is going to be ruined. So let me just delete the temperature first so that we can just focus on this block, these two block only. So because the purpose of this experiment is just want to see the pattern of the data until when it can survive. So it's okay already. We have the Thingspeak over here. They already logged the data based on 1 minute interval. And then we have the Adafruit IO, which are going to be firing the data, if I'm not mistaken, around 30 second. Yeah, around 30 second. So this one are much more faster. So around 30 second without sleep mode, and also what we call it as a deep sleep mechanism. We can just do it at the robust manner. So we shall see tomorrow, perhaps around morning or afternoon or evening, whether these two battery are going to be sustained. So for the current of this module, I already checked it before using this setup. Using similar voltage, we need approximate, they produce approximate 120, which is correspond similarly with our ESP01. However, this one is integrated chip, where the previous setup is actually the embedded module, where we have the Arduino Nano connected with the ESP module and connected with the sensor, whereby we have the Wemos D1 Mini equipped already with the Wi-Fi module over here on board chip, and then we just connect the SDA and SEL accordingly on the board, and then we are going to see whether it can perform or not. In the challenge, in this particular challenge also, we increase the voltage using the step up. So this is a step up converter, where we increase the volume or increase the voltage from 3.7 into 8 volt. So the current withdraw here is approximate around 120 to 150 milliamp, and then we are going to see how long the data are going to be captured, and then we are going to discuss the output tomorrow. We hope that it can be produced much more than what we expect, so that it's meet the nominal estimations of 4,800 milliamp. All right, until then, that's all for my quick diary capacity using this kind of approach. I believe this is one of the best method to know, provided that you know already what kind of current that already being withdrawn from your battery. All right, so we have two approach also. The first one using the Thingspeak, and then another one using the Adafruit IO. We shall see what will happen in terms of the setup and then the consumptions of energy and the battery capacity soon. We are going to discuss in detail the setup of the Arduino Nano and also the Wemos D1 Mini, as I already made the experiment just now. So until then, thank you very much for watching and see you again next time. Bye bye.